Welcome back. So now we're going to talk about exponents. Exponents is the mathematician's lazy way for writing repeated multiplication. What we mean by that, and let's go ahead and start with something nice. Let's say we have 2 times 2 times 2 times 2 times 2. Now that was kind of painful to watch and painful for us to, even see me write. So I have 2 times itself 5 times. The shorthand way to write this is using exponents. I have 2, which I'm going to call my base. And I'm raising it to the 5th power because I've multiplied by itself 1, 2, 3, 4, 5 times. So I have a base, let's call it here 2. And my exponent tells you the number of times you repeat. Sometimes people call an exponent a power. And that here is 5. So we have a base raised to a power. And the way we would write this or say it, if we were to write it in words, is 2 raised to the 5th power. Now, I'm not going to test you on writing it out in words, but I do expect you to be able to read it to me in that proper way. If you say 2, 5, that doesn't make sense to me. 2, 5, is that 25? Is it 2 then space 5? I don't know what you're talking about, unless you say 2 raised to the 5th power, so that I know that this is a superscript. It's a little thing that's up higher, right? It's floating in the air, so to speak. That's what an exponent is. Now, we might be asked to evaluate these things. So let's go ahead and say we are asked to evaluate. What we are going to do is, let's say we got 11 squared. First things first, this means repeated multiplication. We have 11, which is our base, so that's what's being multiplied by itself. And 2 is the exponent, so it's multiplied by itself twice. 1, 2, 11 times 11. That's what it means. It does not mean 11 times 2. So 11 times 11 gets me 121. All right, let's push that further. Let's say I have 3 squared. That means 3 times 3, which is 9. It does not. Let's write it in red. So this is wrong. I would not write this down. I just want to show you instead of verbalizing it. 3 squared does not mean 3 times 2, which is 6, but that's not what it means, okay? So be very careful. This is ugly. I have to scribble it out. I don't even want to see it. It means 3 times itself 2 times, right? 1, 2 times being multiplied together. So be very careful with your exponents. Like our first problem that we did, let's say we're asked to evaluate, this is third, so we have 2 to the, and I write ugly stuff, 2 to the 5th power. What that means, and I'm going to write out what it means, that way I can evaluate. That means 2 times itself 5 times. And I always have to double check myself. I got 1, 2, 3, 4, 5 2s. Okay, so I multiply them all together. It doesn't matter what order we multiply in, as we learned from multiplication. So I'll multiply these 2 together, these 2 together, and that extra 2 at the end. And I still got to multiply further. 4 times 4 is 16 times 2, which gets me 32. And some of you might recognize this number from if you're taking computer literacy. 2 to the 5th power is 32, and usually you have a 32-bit computer, and that's because binary as digits 1 and 0, which is only 2 digits. If you're interested in that, just come see me. I'd be more than happy to talk computer talk with you, okay? So that might be something interesting. People use this a lot for binary, adding and subtracting binary codes. Moving on, though, that's not part of our course. Let's talk about order of operations. Now, order of operations, usually we remember it by this nice acronym, PEMDAS. PEMDAS is confusing to people because the order is misleading. So let's break it down by step 1 always. The P. He's our first thing in order of operations, and it stands for parentheses. And I can't spell, so don't hold me to this. Parentheses. Parentheses can be quite a few things for us. We might see regular old parentheses. We might see, even worse, these square brackets. And the absolute worst thing we'll ever see is the curly brackets. Now, in this video, I'm going to do the easy examples of order of operations. In class, we're going to do the nightmare problems in which we see the curly brackets. It's too confusing to show you online, and I don't expect you to be able to handle it at home. Some of you probably will be able to, but it's just not worth the time and effort. So, moving on, the second thing is exponents. Exponents, which is the E part, is what we just experienced. We'll see some base raised to some power, or some exponent, okay? So that's something you'll see. Usually you have to simplify the base as much as possible if you see those parentheses, because step 1 trumps exponents, okay? So be careful. We'll see an example of that soon. I'm going to have to skip the page to another part. Step 3 is the MD part of PEMDAS, okay? Now, MD stands for multiplication and division from left to right. It does not say multiplication first, then division. It says multiplication and division from left to right. So the way we read. Order is very important to the division world. So if we see it first, we must do it first. Here is a great example. Let's say we have, 16 divided by 4 times 2. Some of you out there will swear up and down and must occur first, so you're doing 4 times 2. You would be wrong. You must do the multiplication and division from left to right. So the way we read. So we start from the left and we work our way over to the right. The way we read. So the first thing I see is division. I will do it first. I have to do it first. The rule says I will. 16 divided by 4 is 4. And 4 times 2 is 8. This is very different if you were to do this wrong. Okay, and I'm going to write it just so you can see it. It pains me to do this, though. So I have 16. I say 16 and I write 12. So I have 16 divided by 4 times 2. So this is horrible. This is wrong. I can't stress that enough. If you do 4 times 2 first, you have 8. And you're doing 16 divided by 8, what you get is 2. Notice it's not the same as the correct answer because it's wrong. It's horrible. Don't do that. You have to go from left to right. Okay? Then, our last but not least step is addition and subtraction. So that was bad, of the PEMDAS, okay? So the ending part. So addition, subtraction, same story from left to right. Alrighty, so now what we are going to do is see a problem that requires us to use all these components. So we have to simplify this expression. So our directions are the vague simplify. Should have wrote that. We got some square brackets, we got some parentheses, we got some division going on. It looks like addition and subtraction and not 2 math shells. So I'm going to write a note to myself. I have parentheses, exponents, if there's any, multiplication, which turned into a crazy M on us. Let me fix that just for pretty sake. Multiplication and division are done at once, so parentheses, exponents, multiplication and division, and then addition and subtraction for the end. So let's start off with parentheses. At first glance, you're probably panicked because you're like, well, there's a billion parentheses. What we are going to do with the parentheses is we start with the regular guys that we're used to seeing. So we're going to start with these. And we simplify as much as possible, following order of operations, inside the parentheses. So we do 4 plus 6, and that's 10. Now I'm anal, so I rewrite the entire problem over again. Since I simplified the parentheses, I usually drop them, if it's safe to do so. There's some situations in the next little bit that we'll learn where it's sometimes better to just keep them. You know what? Let's just do that. We'll just keep it, okay? That way we don't panic about it and say, oh no, you didn't do that before. So we'll keep them there. They're not necessary in this case, but sometimes they are. So to be safe, just write them. So I simplified as much as possible inside there. Now I'm going to look for exponents or anything around him, because if there isn't, I would tackle it, but there isn't. So I'm going to go on and say, okay, I did the parentheses. But now let me do the square brackets, because I'm still in the parenthesis stage of order of operations. Now, I have multiple square brackets going on. I have the first set here, so that is one piece of the puzzle. I can simplify these guys, or I could go over to these other square brackets over here and simplify in there. Because they're separate, it doesn't matter which one I do. If they were all together, then I'd start with the innermost one and work my way out. I'm just going to start with the first one I see from left to right because I like to program myself that way. So starting with these guys, I'm inside the parentheses and I have to follow order of operations. There's no exponents, so I move on. Multiplication and division from left to right. So I start from the left. This is subtraction. Don't do it yet. We're in multiplication and division. And we have 10 divided by 2. Well, what is 10 divided by 2? So that's what we're starting with. We got 5. So I have 22 minus 10 divided by 2 is 5. So now I got to simplify that because I'm still in the square brackets. I haven't finished everything inside of them. So multiplication and division are done, but now I have to do addition and subtraction. And 22 minus 5 is 17. So that's it for those square brackets. So I can move on to the next square brackets. And I'm going to cheat and do it at once, okay? So I'm going to use a different color just so I don't have to keep rewriting it. So here's the second brackets. Now, don't forget, you have a minus sign out front there. So I'm subtracting the two things, whatever I get, okay? So in these square brackets, I'm following order of operations. There's no more parentheses. Move on. There's no exponents, thank goodness. I'm being nice to you. When we do these in class, I won't be. We have multiplication and division next. We have 6 divided by 3. Well, that's 2. I have to do that first. Don't be tempted to go, ooh, 1 plus 6 is 7. No.